When we talk about the most important machine in the world, most likely people will associate it with a machine used in hospitals to treat some recurring diseases that affect a large portion of humanity. Computed tomography scanners use X-rays in cross-sections to create detailed images of the inside of the body, allowing doctors to visualize organs, tissues, and bones, helping in the diagnosis of various diseases such as strokes and internal injuries. It could be a strong candidate for the most important machine in the world. Or even the magnetic resonance imaging machine, which uses magnetic fields and radio waves to create detailed images of the organs and tissues of the human body, allowing the detection of tumors, soft tissue injuries, joint diseases, spinal problems, among others. It could also be a strong candidate for the most important machine in the world, since these machines allow for the detection and diagnosis of diseases and injuries in advance. Not to mention the multi-parameter monitor, the defibrillator, the mechanical ventilator, and the infusion pump, which are all machines of supreme importance for restoring the health of us human beings. However, none of these machines is the most important machine in the world, and none of them is as important as ASML's lithography machines. Each machine weighs 150 tons and has over 100,000 internal parts. It requires a building with atomic level vibration isolation, since just a person walking nearby can cause major errors and inaccuracies in the machine. And this machine costs almost $500 million. Just one machine. And to top it all off, its design phase took about 10 years, the same amount of time it takes to design a modern commercial passenger airplane. But what are these machines for? And why are they considered more important than other machines in the world? Does that include hospital machines? Well, take a look at absolutely everything around you. Cars, clothes, roads, phones, furniture, appliances, airplanes, buildings, construction structures, and so on. Everything is the result of major scientific and technological advances achieved by human beings in the last 50, 100, 200, 500, or more years. And behind all the machines responsible for creating all these things that we literally see everywhere around us, there is a small electronic component that many people have no idea even exists or how important it is, which is called a chip or microchip. It's thanks to this tiny component that everything, absolutely everything we have at home, at work, or even on the street was created, manufactured, or processed. We've put chips in almost everything because humanity relies on them so much. From your iPhone, the electric window in your car, the air we breathe inside an airplane, to your hairdryer. And even in items that don't have chips like a pot, a toothbrush, a glass cup, or a nail clipper. The manufacturing process of these items depends on various machines, which have dozens of chips inside that allow them to work properly. Even the food we eat every day was, to some extent, processed by a machine that has a chip. Okay, but what is a chip and what is it used for? In electronics, an integrated circuit, also called a chip or microchip, is a miniaturized electronic circuit, mainly composed of semiconductor devices. In other words, a chip is nothing more than an electronic circuit made up of several elements, but reduced to incredibly small scales. And the term semiconductor refers to the characteristics of the material they are made of. There are two types of materials: the materials that conduct electricity, like the copper in power wires, iron, gold, among others, and the materials that are poor conductors of electricity, called insulators, like plastic, glass, rubber, among others. And in between them, there are the semiconductor materials, which are kind of intermediaries between good conductors and poor conductors. The main semiconductor elements are silicon and germanium, However, the industry uses silicon more because it is more abundant in nature. In fact, it is the second most abundant element in the Earth's crust after oxygen. It is found abundantly in certain types of sand, and it is from this element that chips are made. However, chips are built on a piece of silicon-based semiconductor material called a wafer. It is on these wafers that microcircuits made up of transistors, resistors, capacitors, and various paths for electric current to flow are built, thus creating a chip. And the fundamental element in creating chips is the transistor, which is an electrical component that acts like a switch, turning on and off, allowing or blocking the flow of electric current. And computers are programmed to interpret this flow or lack of flow of electric current as information in the form of bits, that is zeros and ones. And it's this constant, gigantic sequence of zeros and ones that forms the data or information that computers store, process, or manipulate. Whether it's internet videos, documents, games, apps, programs, among others. But the way chips are made is one of the most complex things, if not the most complex thing ever created by humanity in all of its history. You've probably heard that the new iPhone 16 Pro Max has a processor, the A18 Pro, with 18 billion transistors capable of performing 35 trillion, exactly 35 trillion operations per second or calculations per second. Or that the Samsung S24 Ultra has a processor, the Snapdragon 8 3rd generation, with about 16 billion transistors. Or even that the brand new NVIDIA graphics card, the RTX 5090, has an absurd 92.2 billion transistors, giving the card unprecedented processing power. But how is it possible to fit so many transistors in such a small and compact place, less than 3 centimeters, which is the die of the card? The answer lies in the major technological leaps that made it possible to reduce the size of components, especially transistors, to atomic scales, allowing billions of transistors to be placed in the same space. This produces more powerful, efficient chips. This ability to shrink the size of transistors is so incredible that currently the transistors used in chips from Intel, Apple, or Samsung can be as small as 3 nanometers in length. A nanometer is equal to 1 meter divided into 1 billion parts. That's so small, but so small that it's even smaller than the thickness of a human hair, which is about 90,000 nanometers. Smaller than the size of a virus, which is 14 nanometers, and smaller than the cell membrane, which is between 10 and 5 nanometers. There are currently transistors of only 2 nanometers being researched and developed, with their size being equal to the diameter of our DNA strand, the famous thread that carries the genetic code of all living beings. And as you can imagine, making things this tiny requires not only incredible technology, but also machines with extraordinary precision. Since besides the component being extremely small, there is a tiny distance between one transistor and the next, which is right beside it. It's just 2 nanometers plus a wire that allows energy to pass from one to the other. This occurs throughout the chip's billions of transistors. And this is where the cutting-edge lithography machines mentioned at the beginning of the video come in, where just a person walking nearby can cause major errors, inaccuracies, and misalignments in the chip that the machine is manufacturing. Currently, the most advanced chips in the world, which are used in laptops and PCs, next-generation gaming devices, data center servers, cell phones and tablets, cars, smartwatches, and hundreds of home appliances. A multitude of military equipment, such as fighter jets, missiles, and bombs, as well as thousands of other machines and devices, are manufactured by one single company in the entire world. by the giant TSMC, Taiwan Semiconductor Manufacturing Company. It is the largest and most advanced semiconductor factory in the entire world. This means that it manufactures the chips that other giants such as Apple, Nvidia, Qualcomm, Intel, among hundreds of other companies, use to make their own products. This is such a huge monopoly that this Taiwanese multinational is responsible for more than 90% of the world's advanced chip production. It's among the world's 15 most valuable companies, with a market value of $500 billion and annual revenue between 70 and 90 billion. TSMC's factories are ultra-modern and ultra-advanced, and they're called fabs. The fabs operate in ultra-controlled and ultra-clean environments, with dust levels millions of times lower than regular air. They use ISO 1, allowing up to 2 particles of 0.5 micrometers per cubic meter. That's 100 times cleaner than a hospital operating room, since even the smallest particle can ruin an entire wafer. Since the factory operates on a nanometric scale, people don't control production. Almost everything runs automatically, needing minimal human input. The wafers travel through various machines spread throughout the factory and are delivered to each one by the front opening universal port, which protects the wafers from contamination and damage. And it moves along the factory ceiling and carries up to 25 wafers inside. Once delivered, a robot removes the wafers one by one and inserts them into the machine, which operates in a vacuum. And it will perform a very specific step of the complex manufacturing process, where materials can be added, removed, polished, or processed. Afterwards, it will be taken again by the front opening universal port to another machine, and so on. To give you an idea of how complex modern chip production is, we can make an analogy and consider a computer's CPU. Making a CPU, central processing unit, is like baking a cake with 80 layers, where each layer is different from all the others in size, ingredients, and geometry. To make this cake, there are 940 different steps in the recipe, with exotic ingredients, solids, liquids, and gases, and the cake takes 3 months to be ready. And what if in any of the 940 steps the ingredients are 1% more or less, or if the oven temperature is 2 degrees higher or lower than the ideal point? In one of the 80 times a layer goes into the oven or mixer, it shifts half a centimeter from its intended spot. If any of the batters go wrong, the whole cake is lost. At TSMC, something exists. Around 500 to 800 more different machines for chip manufacturing, with a global number of over 3,000 machines per gigafab, since many of them are repeated. The chip manufacturing process is divided into 6 groups performed by machines. Those that make the mask layer, material addition, material removal, material modification, wafer cleaning, and those that inspect the wafer. This process takes about 3 months per chip, and it consumes about 99,000 tons of ultra-pure water per day. It's among the world's most water-intensive industrial processes. And this ultra-pure water is the cleanest water in the world, being much cleaner than distilled water. This water is used to wash wafers after each step, to cool equipment, to prepare chemical solutions, among other uses. Even in terms of energy consumption, the process is intense. To give you an idea, in 2023, TSMC alone consumed approximately 25,000 gigawatt hours of electricity. This represents about 6% of Taiwan's total energy consumption, surpassing the consumption of some cities, such as the capital, Taipei. While TSMC manufactures the most advanced chips in the world that giants like Apple, Nvidia, and Intel use to make their most advanced products, the Dutch company ASML manufactures the machines that TSMC uses to make the chips. And the main one is the advanced lithography machine, high NA EUV, which works as follows. Everything starts with light, but not just any light, a light as short as our DNA. Called extreme ultraviolet, or extreme ultraviolet with a wavelength of only 13.5 nanometers, equivalent to 5 strands of DNA side by side. This light, which is absorbed by absolutely everything, including air, requires the entire machine to operate in a complete vacuum. This extreme ultraviolet light is generated by bombarding droplets of liquid tin at a rate of 50,000 droplets per second. These are hit by a carbon dioxide laser with a power of 50,000 degrees Celsius, hotter than the surface of the sun. With this, the tin is vaporized and emits ultraviolet light photons. However, this light needs to be captured, directed, and shaped in the right way. And for that, the machine uses mirrors made by Lamar Zeiss, which are the flattest and most perfect mirrors ever made by all of humanity. Since you can't transmit ultraviolet light through lenses because they absorb this light and also create distortions, all the optics of the machine are made with more than 7 highly reflective mirrors, operating with precisely calibrated reflection instead of refraction. Along this path, this light will pass through a mask that contains the pattern of the chip you want to make, which would be that complex network of paths that forms a chip. After passing through several more mirrors, this light finally reaches the wafer, which is coated with a light-sensitive material, and in this way, the pattern is recorded onto the wafer. However, since a modern chip has between 80 and 100 layers, this exposure process is repeated 80 to 100 times. Saying it like this, it even sounds like a simple process, but as is very well reported both on the ASML website and on the Zeiss website, the complexity and precision of this are truly absurd. The light needs to hit the wafer with atomic precision. This means that the robotic arm that inserts the wafers into the machine, the moving parts that move the wafer inside the machine, need to place it in the right spot with atomic precision. If either the wafer or one of the mirrors is misaligned to the left or right, forward or backward, or slightly tilted by the width of a human hair, the whole process will go wrong. On top of that, if during the exposure the machine vibrates or shakes even a little, the exposure will be wrong. If there is air, moisture, static electricity, or magnetic fields present, the exposure will be wrong. That's why the new concept of mechatronics for the various moving parts of the machine had to be developed so that they move with absolute precision. On the Zeiss website, they say that the motorized mechanism that aligns these mirrors can align them and allow them from here on Earth to reflect a light and hit a ping pong ball on the surface of the moon. The Zeiss mirrors, besides being made with something like 40 layers one on top of the other, of alternating molybdenum and silicon, are polished with a precision of less than 0.1 nanometers. In addition, they have real-time temperature and deformation sensors, controlled by artificial intelligence. Everything in this machine operates with extreme precision. That's why it's so expensive and complex. And this machine produces the chips that dictate the technological advancement of the modern world, like the advanced chips from NVIDIA, which are responsible for powering ChatGPT, and the chips in the most modern smartphones. 5G technology, autonomous and electric cars, industrial automation, and many other areas are direct beneficiaries of 3 nanometer chip technology, nanometers, made by what is considered the most important machine in the world.